Welcome to the second session of Module 2. This course will enable students to understand various sources of IoT and M2M communication protocols and describe cloud computing and design principles of IoT, become aware of MQTT clients, MQTT server and its programming, understand the architecture and design principles of wireless sensor networks, enrich the knowledge about MAC and routing protocols in WSNs. These are course objectives. At the end of the course, the students will be able to describe the OSI model for the IoT systems or M2M systems, understand the architecture and design principles for IoT, learn the programming for IoT applications, identify the communication protocols which best suits the WSNs. These are course outcomes. In this session, we are going to discuss about internet-based communication, Internet Protocol version 4 and Internet Protocol version 6. Internet-based communication, source and network layer that will communicate with IoT or M2M IoT apps and service layer. It uses TCP/IP suite of application protocols and also connect through set of IP routers for sending data packets from an IP address. Here we can see source and network layer connected through set of IP routers for data packets from an IP address and communicating with IoT or M2M IoT apps and services layer using TCP/IP suite of application protocols. So here the device or the machine that is connected to the smart sensor. So it represents the IoT. Here we have IoT communication frameworks, application framework, and this smart sensor that is connected to the gateway. So here the data consolidation that is going to occur in the gateway, and the gateway that is between the sensor and the routers. So we have several routers. So in particularly for the internet protocol, we have set of IP routers. Okay, in this end we are going to define the source and IP addresses, and these routers, particular router which is connected to the machine. Okay, so from that router the data packet that will reach to that destination and IP address. The data will enter into the physical data link layer. So this is the TCP/IP protocol, and to the data link layer the data will be moved to data link layer and then to the network layer, and here it is going to check the destination and IP address, and again the data will move to the upper layer, that is transport layer, and to the application layer, IoT application layer of TCP/IP application protocols. In the same way, if the machine wants to request something from the smart sensor, the data will be moved in the reverse direction, that is from application layer to transport layer to the network layer, and here it is going to add the destination IP address and to the data link layer and the physical data link layer, and the packet that will reach the routers and particular router that is connected to the sensor through the gateway. This is how the communication that is going to takes place. Source and IP connectivity. So as it is a source and IP, it uses source IP address. Source and network layer connection through set of IP routers up to the destination IP address. And smart sensors, IoT communication framework and application framework that will connect to a gateway. It is going to connect to the gateway. The gateway has the capability of data consolidation and the data enrichment, and also it performs transcoding. The framework that uses IP routers to destination, which is identified by another IP address of destination. Internet connectivity that will happen through set of routers in a huge network of routers which carry data packets as per IP protocol from a source end to another end, that is destination end, and vice versa. A source sends a data packet in IETF standardized formats to destination, and each packet flows towards destination through set of routers. In the internet we can find several routers, and each router will have its own routing table. Depending on the routing table, it will find out that which is the best suited path to reach the destination. Through that path, the router that is going to forward the packet. And we have a concept of layers. So we have 5 layers in TCP/IP. Consider from transport layer to the internet layer, the data will be forwarded or moved, while receiving from internet layer to the transport layer, the data will be moved in the upward direction. In internet communication, we are using the layers between the source application layer and destination application layer. So we have two machines, one is for the source and another is for the destination. Top layer is application layer. Okay. When data transmits from a layer I to next layer J, the actions performed at each layer as per the protocol used for communication by that layer. Consider in transport layer, if we are using the protocol TCP or UDP, depending on the protocol, if you are using UDP protocol, so it will use those rules to make the packets that are suitable for UDP protocol, and that will be moved to the next layer. So that means that the rules that must be followed of what is the protocol we have used. Each layer sends the data stack received from the previous upper layer plus sends a new header along with that stack, and thus creates a new stack after performing the actions specified at that layer. We can see here. So here the data that has been generated. So if it move to the next layer, that is the transport layer, so it is going to add its own header here, and the complete header plus data that will reach as a single entity to the network layer, and it is going to add its own header, and the complete data as a single entity that will reach the data link layer, and it is going to add its own header. Okay, so while that is called as the encapsulation, decapsulation is in the reverse order. So this header, data link layer header, that will be removed at this layer, and the network layer header that will be removed at this network layer, and the header of the transport layer that will be removed here, and the original data that will reach the application. That is called as decapsulation. This is what layer how we can move the data from one layer to another layer. So we have PDU, that is protocol data units. Each layer has a specific PDU. A data segment maximum 2 power 32 bytes per segment. From L7, that is layer 7 layer, generates a TCP stream at the transport layer using TCP for transmission. TCP stream received at transport layer consists of packets from internet layer of PDU, maximum of 2 power 32 bytes. This is a TCP IP suite, 4 layers model generating data stack for the network and for physical layer during internet communication. Physical layer, that we can call it as L1 layer, and data link layer L2. So we are going to add the header as well as we are adding the trailing bits, and the network layer, that is L3, and the TCP layer L4. So we can use either TCP or UDP, and this is the application layer. So that is L7 header. So here at the application layer, PDU is equal to 2 power 32 bytes for applications and services, and for L3 it is 2 power 16 bytes, and for L2 and L3, so it is 1580 bytes. Layer J will next specify the new parameters as per the protocol and creates new stack for next lower layer. The process that will continue till data communicates over the network. Upper layers use the header words alone. Lower layer such as data link layer protocol such as Ethernet use trailing bits also in addition to the header words. Here we can see that L7 layer that will use as the header, L4 layer that is going to use the header, okay, and L3 layer that is going to use the header, but at the second layer, that is layer 2, at the data link layer, so we are going to use the header as well as trailer. In the trailer we call it as trailing bits. So those trailing bits that are used for error control. Trailing bits usages can be as error control bits and end of the frame indicating bits. It's going to use for error control bits, and it also indicates end of the frame. And we will discuss IPv4 and IPv6 protocols, but protocols that are used in internet layer. This internet layer that receives and forwards data to next stage. It can use IP version 4 or IP version 6 or IP version 6 routing protocol for low power lossy networks in IoT or MDM, or 6 low PAN in IoT or MDM. Coming to IP version 4 protocol, IPv4 protocol headers and data stack. TCP header plus data consist of stack from the transport layer. From internet layer, each packet consists of 5 words, basic IP header fields of 160 bits and extended header up to n words. One word is equal to 32 bits, n is equal to total number of header words added at IP layer. So you can see here data stack received or transmitted at R2 transport layer, and a packet consisting of IP header fields of 160 bits and extended header n is equal to 5 words plus a data stack of maximum v words from R for the transport layer. This is for IP version 4. These 4 bits from 0 to 3, so that will represent IP version, and 4 to 7 bits that represents service type and precedence, and bit number 8 to bit number 15 that will represent service type and precedence, and bit number 16 to 31 that will represent length, IP packet length, and first byte sequence number in the string. So we are going to use several flags, and we can use fragment offset, and what is the checksum we have calculated that has to be matched at the destination, that calculated checksum, and the type of the protocol, and how much time the packet that must leave, time to leave, and we are going to add the source IP address, we are going to add the destination IP address. So if any difference, so if it is not matched for 32 bits, so we are going to use the option header words and fields plus the words as padding before the data. And then we have data of length minus n words, so this is maximum. So this is the actual header, and this is the extended header, and this is Q. N is a number of words, that is equal to 5 words for header plus options plus padding words. Data packet from R to transport layer, maximum size, that is 2 power 16 bytes. IP version 4 header and data stack to next stage. IP header first consists of 5 words. The header extends by using option words and padding words. Data stack to network layer has maximum v is equal to n plus length, where v is less than or equal to 124 minus n words. Packet size maximum is 2 power 14 words, that is meaning 2 power 60 bytes. Header first word fields bit number 0 to 3, that is IP version, 0100 that represents the version 4, that is IP version 4. 4 to 15 service type and precedence, 16 to 31 IP packet length in words, and 32 to 46 first byte sequence number in the packet of the TCP stream, 47 to 50 flags, 51 to 63 fragment offset, that will specify which data stack length words consist of which fragment in the data stack of transport layer, and 64 to 71 bit numbers, time to leave, number of hops try to reach to destination, and bit number 72 to 79 type of protocol. Here we can use any example like ICMP, Internet Control Message Protocol. 80 to 95 bit numbers, checksum, sum of header bits that is going to be calculated before sending the data, and 128 to 159 that represents 32 bit destination IP address, 96 to 127 bit numbers that will represent the source IP address. So this is about IP version 4 protocol. Next we go for the IP version 6 protocol. The features are, it will consisting of large addressing space and root aggregation. Why the large address space is? So we are going to use 128 bits to represent the address. in IP version 6. In IP version 4 we are going to use 32 bits. So that's why it is having large addressing space. So it is vastly enlarged address space compared to IP version 4. An IP version 6 address fields provides a numerical label. It identifies a network interface of a node or other network nodes and subnets participating in IP version 6 internet. A device called a node when it communicates on a network. It permits the hierarchical address allocation, and thus it can perform route aggregation across the internet. So therefore limit the expansion of routing tables. And it also provides provisions additionally for optimization for the delivery of services using routers, subnets and interfaces, and it also manages device mobility, security and configuration aspects, and expanded and simple use of multicast addressing provisions, jumbograms, big size datagrams we can use, permits extensibility of options. This is about IP version 6 protocol, and this is the reference I have used. The contents I have obtained from the textbook Internet of Things Architecture and Design Principles, written by Raj Kamal and published by McGraw-Hill Education. And that is the end of session 2. Thank you.